Welcome everyone to Paleo Talks 2025. This is the second one, presentation by Francesco, whom we thank a lot for accepting our invitation and be the second speaker. And
Thank
we
you
are
everyone for 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 the possibility to talk here.
it's a pleasure. It's always a pleasure. So we are very excited to see what you're going to show us and learn more about dinosaurs. I'm a shark paleontologist, so everything is new for me, and I'm for sure going to learn a lot from you. So
Okay,
I'm going to get out and leave the stage to you. And thank you.
thank you. Okay, so a little presentation. I'm Francesco Lategano. I'm actually a freelance geologist and do work do a paper about the biomechanics of the tail of Miragaia longicolum. Started as my master thesis and then become my first and actually only work published. So let's start. If someone asked, yes, this is a frame of modified of Jurassic World Evolution, so doesn't hate me for the dinosaur from a game. But let's start. Miragaia longicolum is known as the most complete and well-known stegosaurus of Portugal, and we know from the two paper from Matheus 2009 and Francisco Costa and Octavio Matheus 2019, there are three specimens known of Miragaia, and the peculiarity of these stegosaurs is the neck with 17 cervical vertebrae. That is attest as the only stegosaurs with this characteristic of a long neck like sauropod. Last year, a study from Sanchez Fenolosa et al. Suggests the possibility that Miragaia longicolum will be a subjective junior synonym for Dacentrurus armatus, but this doesn't affect my work because it was published during my paper was on uh, revision, so it was just a curiosity I want to add. The materials I've used here, the elements that compose the tail, I focused on the movement of the tail, as the title says, and belong to the spaceman of MG4863, studied and reconstructed by Francisco Costa. And the elements are 42 caudal vertebrae and 22 caudal spines, as reported from the model that you can see that was being reconstructed by Francisco Costa itself. For the study, I have used two approaches. The first one was a numerical simulation of the tail using MBDyne, a program, a software for the multi-body dynamics study, and then the study of the physics of the impact of the caudal spines, because Miragaia have a peculiar shape of caudal spines that I will show you. The final goal of the work is to reconstruct the possible movement during the life and try to reconstruct some ethological hypotheses. The model is an exemplification, of course. It possesses a fixed position that represents the sacrum. All the caudal vertebra is represented from with the cylinders, while cones represent the caudal spines, and the movement was imposed only on the horizontal plane, so it moved on the x and y axis. So, start with reconstruction. As said, the model is tested on MBDyne, a software developed from the Politecnico of Milan. I started with eighth vertebra, eighth caudal vertebra of the tail of Miragaia longicolm because it was the most complete and well-preserved vertebra of the tail of the specimen MG4863. And then I estimated the length, height of all the caudal vertebra of the tails, and then I estimated the intervertebral cartilage length between every caudal vertebra, as you can say, as you can see. And the tail movement was imposed to the first 8 bodies, or the caudal vertebra, and that was based on the work of Conti et al. On the Apatosaurine dinosaurs. The joints simulate the action of the cartilage and tendons of the tail, and we have our revolute joints that join whole bodies and permit only an horizontal movement, and then a deformable joint that give stiffness and jumping to the model. The 8 first bodies was limited because we have the transversal process till the 16 or 28 vertebra, but if we give the movement if we impose the movement to hold the vertebra, we could have a movement not so realistic, and maybe we could have a force and speeds very high, which we have in any case, but the caudal spine structures is peculiar for us stegosaurs, is differ from Stegosaurus stenops. We have a narrow spine with a large base that someone supposed has suggested that could be maybe the spine that belong to the shoulder more than the tail, but there is no study. So Francisco assured me that they are the base of the tail of the spines of the caudal spines. When I reconstructed, I used 50% of the cancellous bone for the caudal spines, then 16% for the compact bone, and then 33% for the keratin layer to obtain a 150 centimeter of length. The peculiarity of the caudal spine, sorry, the peculiarity is their cross-section. Their cross-section are sigmoid rather than elliptical, like in Stegosaurus stenops. And that, to test the mechanical behavior of the spines, I've just simplified the shapes of the cross-section in a rhomboid shape, just for mathematical reason. This is the arrangement that I suggest in my study, which we have a Kentrosaurus arrangement with the spines follow a certain type of degree in dorsal view, but are not so. They have not a degree progression in a lateral view, while the arrangement I try to suggest is the Miragaia longicolm arrangement that is was inspired by the reconstruction in Laurinia Park. I didn't remember the name of the park where there is this the reconstruction of the animal in life, and I reconstructed with a degree of 6 grades and 6 degrees in lateral lateral view, and this shape of the spines that opens till the ends are more narrow, more near in at the start of the tail, at the base of the tail, and then go to open till the end, till the tagomizer. The method of the impact force was found. The speed of the tail was found with MBDyne. But after that, we applied the paper and pen method to find the momentum, the force, and the stress that the tail could produce. For bending and compression of the caudal spines, we tested with only mathematical methods, and we test the bending and compression and compared to that of Stegosaurus stenops, because Stegosaurus stenops is the well-known Stegosaurus, and we have a proof of combat behavior against Nalosaurus fragilis from Carpenter et al. 2005. And as we can see in this representation, we see the Stegosaurus stenops have a more bulkier caudal spines, while that of Miragaia longicolum are more narrow, as said before. Here a reconstruction of the movement. I hope you enjoy. This is at 12 meter per second, and as you can see, I applied a little movement to the body, but it's just to show how much the tail could move, and to try to see if some of the range that the tail could if the range of the tail could in some way try to hurt the animal. As you can see in this simulation, the Argomizer hurt and penetrate the shoulder of the animal. Okay, the impact force we have reached are done with different stopping times. We know that Stegosaurus stenops could bear 316 and 510 Newton from Carpenter et al., while Mallison with Kentrosaur etiopicus could generate 50 kilonewton with a 20 meter per second swing. We used four time stop to have a more ranged results. I've used 0.5 as an optimal time stop, 0.333 that used by Carpenter et al. And used also by Harbour for Ankylosaurian, 0.05 that was the time used by Mallison, and at 0.85 milliseconds that is the time stop of a baseball hitter, and tested with 4 speeds with the model in MBDyne we obtained. So we have a 12 meter per second, 7 meter per second, 20 meter per second, and 26 meter per second. And we can reach a 0.84 kilonewton with the slowest 0.5 second time stop and the monstrosity of 1074 and 54 kilonewton with the 0.85 milliseconds at 26 meter per second. For the stress, the tail could generate is estimated an impact area of 0.28 by Carpenter and have 13 to 80 megapascal, which suggests is sufficient to harm tissue and bone. The stress it could bear is enormous. It's 0.03 gigapascal at the slowest time stop, and it could be 38 gigapascal with the fastest. I'm sorry, with 0.85 milliseconds. About the mechanical behavior of the spines with bending and compression, we've seen that in bending and in compression, the caudal spines of Stegosaurus stenops were better than that of Miragaia longicolum, and that's is not only on the major axis but around the minor axis too, not only in bending but also in compression. And as you can see, we test with the same length, so 1 meter for both the spines. So we say maybe the same length could give us some sort of difference, and then test with their real length. So that of Miragaia, were tested to 1 meter, and that of Stegosaurus stenops were tested on 0.75 meter. And in any case, stegosaurs were better on compression and bending too. The conclusion I reached that was that Miragaia longicolum model was capable of reaching realistic speed, because 12 meters per second and 26 meters per second, it was a good and reasonable speed. After that, the model broke. And the model reached forces greater than that of the Stegosaurus stenops, and that could be to the higher weight of the Tagomizer that reached 35 kilogram with all four caudal spines, and close to that obtained by Kentrosaurus aethiopicus that used a time stop smaller than 0.33 suggested by Carpenter. The ethological hypothesis I've done was that maybe the number of caudal spines and the um, mechanical behavior that are more not so bulky, not so resistant as that of Stegosaurus, maybe could suggest that Miragaia longicolum used the tail more to discourage predator from attacking than used actively as a method to combat, to fight, like modern porcupines. And hope you all enjoyed this fast presentation, and thank you all again.
Thank you so much, Francesco. This was very, very good, very nice. I can only wonder how many hours you input to make this type of to have the results, analyze them, and then reach conclusions. This was your whole master's degree, right?
Yes, was my master degree thesis, and then become my, as I said, my only work on published till now.
Nice, nice.
I hope not last. I hope.
It's the first. It was the first of many.
Yes, was the first of many. I hope. I hope yes.
Okay,
Yes.
guys, everyone watching, if you want to question Francesco about his work, this one or anything else, you can do so by asking to speak on the stage, or by writing on our chat room, which is blinking with all the messages that have been written there so far. While they are writing, I'll kick it off with one of my own questions. You only did digital models, right? You only created mathematical models.
Yes, I've created the 3D model using the Embidyne program, Embidyne software, and then because Embidyne create only simple shapes, so cylinder, cone.
Yeah.
I use the Blender to create every single caudal vertebra.
Mm.
Francisco Costa sent me, unfortunately, late in during my master thesis, the scan he was working, but was unfortunately because we doesn't have he have some issue of communication. He was very busy on his work, so
Yeah,
I thank him
of course.
for the collaboration, and I
Sure.
just model create the model for each vertebra basing on Kentrosaurus and Stegosaurus skeletons.
Okay, okay. I was asking about the digital model because
Yes.
thinking if it was interesting or if you thought about doing the physical model, like trying to replicate with modern materials. I know that it is very time consuming, and in a master degree, it's not very easy to do such things. But if that crossed your mind, or if that's something that you're interested in doing in the future.
Yes, it will be it could be a very interesting team. It will be a very interesting work to do. And I've suggested something. I was talking with at the time with Simone Conti, that was my co-supervisor during my master thesis, and then become one of my collaborator in the paper. And we talk about the physical model, and it it could be we could do a physical model, but will be very very difficult to do.
Hmm.
That maybe he was say because maybe the material, maybe the you need to find the right materials. You need to find someone who give you some funds to do this, and it will be interesting,
Hmm.
interesting. And I hope to do in the future if someone will be interested. But for now, I didn't see the possibility
Yeah,
to do so.
of course.
But
Of course.
it will be very interesting as a work.
Maybe for a PhD continuation work. Maybe for that.
Oh, well. I will think about maybe I will try to suggest someone if I accept my PhD project.
We hope so. We hope so. We have a question by Lucas. Thank you for the
Yes,
interesting talk.
where
So it's in on the chat room. I don't know if you can reach it.
I
Of the tavern
didn't.
store. You must have like a blinking something with notes, like an icon for chat. I'm going to try
Okay.
to answer there.
I have ranking boards introduce yourself, but oh, okay.
I mentioned you in there, so you can see it.
Okay, yes. Okay. Okay. Yes. You know.
Mm.
I don't know if there is some evidence, but I know that this is assumption is more an assumption, but we know that it's more than possible that the caudal spines and maybe also the dorsal plates of Stegosaurus dinosaurs were covered in keratin. It I know there was some work about Alcovasaurs, if I doesn't remember wrong, and also someone study Sophie itself, but at the time was just something I was just informed. The studies was in a work in progress, so I don't know if they have already published or not, but I know for sure that someone is studying this uh, the the possibility that the keratin sheet of the caudal spines and the dorsal plates on stegosaurs could be there. So someone is studying this.
I think you answered it. I think you answered the
Okay.
question. We have two more now from André Bastos, and then Lucas. He has another question. So
Okay. I
again,
don't talk about this.
they write a lot. They are very very lengthy on
Yeah.
their face.
Okay. For the movement, Kentrosaurus, the Kentrosaurus orientation could be a little bit, as I can say, maybe if I can show in the video, I can just. Okay, so I use my and my functions. Okay, as you can see here, I use the Miragaia orientation because the Kentrosaurus orientation were a little bit from more oriented and in the external. So maybe during the movement, the caudal spines near the base could hurt some way the animal, and at the same time, uh, the caudal spines on the base of the tail were more a deterrent. But the difference, then I studied well I studied better the two orientation and see that the ones of the Kentrosaurs doesn't go to do any damage to the animal because they were oriented in a way that maybe the base of the caudal spines go to touch but not hurt in any way the animal. The orientation of Miragaia longicolm I suggest is more to kind of scare the predator, deter the possible attack from behind, and leave the possibility to fight back with a lateral strike. Oh, okay. Thank you for your. I know, I know. The difference is because the Carpenter used a 0. As said, the stopping time is the focus of of the of the reason why they differ so much. Carpenter used at 0.33 seconds, while Malison used at 0.05 seconds. And in the study, he explained that he read and used the time stop from a footballer. So the time stop of a foot that hit a ball that it was like 0.05 seconds. And also why also because the Tagomyzor Kentrosaurs were lighter than that of Stegosaurus. and was absurd. I know because from 350 newton to 15 kilonewton, and that's the only reason I could found in the work. And also when I studied the stopping time, I see that using a stopping time really short as 0.85 milliseconds, that was that a hitter of baseball uh, create an energy, a stress, a force of impact really high. So the only reason I see it was the time stop, and also of course the weight of the tagomizer. The tagomizer of Miragaia launch column I found is 35 kilogram. That is a really heavy tagomizer. It's more like a club of an ankylosaur than a tagomizer of a stegosaur dinosaur. And in the paper I published, I done a comparison with the ankylosaurian dinosaur too, with Euplacephalus, if I doesn't remember. And the club, of course, the club of an ankylosaurian dinosaur is heavier and produce a more high um, force of impact and stress than Miragaia longicolum 2, with a 0.33 seconds of time stop.
Okay, we have another question by Eric. Actually, two questions in the same.
I don't know, but mm, I don't know if it could be not very sociable, but I think it's not. More spines. I try to um, think of dinosaurs in general, not only Miragaia in this case, but all dinosaurs as not only reptiles related, but also birds related. And birds are very colorful and also uh, sociable animal. And Miragaia could have used the numbers of the the big herds, we said, to scare potential predators. And in Portugal, Iberian Peninsula, we have really big theropods dinosaur. So maybe it was I think it was not a solitary animal, but more a group animal, maybe with couples of males and females, with the youngs that fight with more like dances than a real fight, because you don't want to kill someone and then hand your species. You want to show how much you are strong, how much do you could prove your masculinity in a sort of way. So more spine you have, uh, and more you can show them, and in a sort of way you can try to scare your opponents, and more you could be a winner for the females, for the food. And so I didn't think it could be a not sociable animal, but more a very sociable animal. The upper spines were like the antlers of of the a deer or a moose.
All right. While Eric is typing, I'm going to ask another
Yes,
question. Um,
yes, yes.
you've ended your master degree right now, or are you still going to defend your thesis?
Uh, no, I handed my master degree in 2023. So
Oh,
I have 2 years of freelance work as a geologist here in Italy.
okay, okay,
I'm
okay.
searching for a PhD for everywhere,
Okay. I was
but
going to ask you about that. If you're like looking forward for a PhD project, if you're trying to see about that in Italy, but also in Portugal, if that was something that you would be interested in coming back to Portugal to do your PhD, and
I
if you're trying to continue your work, or if you're like looking for something else, like another type of project with like modulation, but for another dinosaur. Curiosity is
oh,
a
of
curious
course,
question.
of course. I'm interested in I'm a dino nerd. Okay, so everything concern dinosaurs. I'm very very interested. I'm searching for a PhD about dinosaurs,
Mhm.
but of course from somewhere I need to start. So if not dinosaurs but paleontology related, it could be very very nice too. And not only here in Italy. Here in Italy, paleontology is doesn't seem so paleontology of dinosaurs is doesn't seem so good.
It's difficult to
But
find like financial support funding for research on paleontology in Italy.
I don't know this, but I can say that I didn't found
Yeah.
many project about dinosaurs,
Mhm.
and if there's some project, they have already someone it's working on. So I someone said to me to try to suggest some project to someone and hope to find someone interested,
Yeah.
and then the university could say yes we are interested or no. Basically no.
I get it. Like we instead of searching for a project which already exists, you could like suggest a project to advisors, researchers in hopes that they accept.
Someone said yes.
um, Yeah,
Someone says that you could suggest a project, but of course they can took your project
yeah,
and found directly. They took your project and they say, okay, your project, I will fund your project, but you need to work on my project too.
yeah,
So
yeah.
uh, then someone said that depends on the university in Italy you try to go, but I didn't found already. So when if find here in Italy, I will I
You let
I
us
will
know.
say to you if
Okay,
which are the difference.
nice. You can also, I don't know how it works for foreign students, but I think in Portugal we have like funding for PhD students who are trying to propose themes. And I believe that
Okay.
the foreign people can also try to make submit the application for this type of fundings, because we have several Italian, French, some even American, like trying to submit applications and even winning
Yes.
like support for PhD here. So you could try that as well. We have the
Okay.
dinosaurs at least.
I have known Simone Conte that worked there in at Nova
Yeah,
no, no,
university.
I don't. That isn't. yes, at the University Nova of Lisbon, and I really appreciated the effort it gave to me to help me
Yeah.
in understand the academic world too.
Maybe you can. Maybe you can try it. I think
I
the
hope.
applications are closed right now for those type of PhD
Yes,
funding.
if I doesn't remember, September is the second cycle, the second batch.
I
If
think
I
yeah,
doesn't
it's
remember
second
wrong.
round. Yeah. So you should try. I
Okay,
think you
okay.
should try.
Of course, I will try until I will success. So
Nice. I was thinking.
absolutely.
I think I saw Andre trying to type something, but then he's typing again, so he is trying to
Okay,
type something.
okay.
Oh, let's see if he takes a lot. Andre,
I
Andre,
really
you have to write short sentences, like submit several short ones instead of like a big text.
okay. I really thank you all to to the attention and to to stay here to listen to my bad English.
Oh, not at all, not at all. And you're very much welcome. And I thank you for being here. And I'm expecting that in future, like 1 year from now, you will say that you want to present something new, and we are all for it. We will
I
welcome
hope
you for a new one, for a new round.
I hope so. I really hope so. Thank you.
Josh only entered the presentation like in the end, in the tail end of it. But it was a very nice one.
Well, what we can say, Miragaia was a punk. the, the, the end at the end, my paper says that Miragaia was a punk.
Okay. We have some last minute comments. Mhm. Oh, okay, okay. So the PhD scholarship at Nova is already closed for this year.
Yeah,
So
yeah.
you have to try to submit next year. You'll have more time to
I will
create a
try to. Yes, I will try to create something and then try to apply.
yeah. I think so. I think you'll be able to. Okay, I think everyone is like
Thank
saying
you.
goodbye. Yes. Oh, okay. We have an illustrator with us.
Oh,
Josh.
nice.
Hey.
Well, if you want, if you all want, I share my DOI of my work.
Mhm.
Uh, the DOI is here. I got
And Josh, you can talk with Francesco through our Discord because he's also a member.
yes.
So you two can talk all you want about the presentation and Miragaia and see if you can collab.
I I I'm honored if someone asks me for
Like input.
a consultation for for an illustration.
I think it will be a good work for you to work out. Okay,
Yes.
so no more questions. We can go. And thank you so much, Francesco, again. I hope to see you in the
Thank
next
you
Paleo
all.
and to be able to collab again in the future. So
I will wait next talk, so in the public, but I will wait.
nice, nice. Oh, we have like a sneak peek. Josh published a
Ooh,
sneak peek of his illustration. Awesome.
whoa, it's awesome. Whoa, whoa, whoa. Nice work.
Like
Nice
a
work,
little,
really.
like a little, like something that he's done like on the coffee, like drinking coffee. Amazing. Simply
Yeah,
amazing.
it's really good.
Josh,
Nice, man.
you are also invited to like do a presentation about your illustrations. Like show us how you do this, what's your process and everything. I think everyone here will be like very into it to see our presentation.
Yes, I
Let,
am
us-
one
let us
of.
let us
I'm really interested.
let us see if Josh, if he bites the invitation and join us as well. Yeah, he was writing. He was writing. I don't know. Let's
Yes,
see. Maybe he will be one of our Paleo Talks speakers as well in the future. We have more people in the
for
works.
paleo art.
I would like to have more paleo artists and illustrators as well. I'm trying. I'm trying. If you know anyone like Francesco or everyone in the audience, if you know people who would like to present their works, please let me know about that. Like, make the connection, bring them to our community, and we'll make it happen.
I,
So it's open to everyone.
as said, I will try to say to the group of Pipe here in Italy. It's the paleontology in progress, and we are the young researchers of the Association of Italian Paleontologists. So maybe I try to link you with with them.
Let's go. Let's go. I'm all for it. We want we
Okay,
want
good.
want many more people like talking about what they are doing, like doing collabs with people here, trying to go forward on their research. So yeah, the same that said to Josh, I said to you. Let's talk about it. Let's make it happen, and let's go forward with
Yes,
more talks.
yes, yes,
Okay,
yes.
guys, let's go. We are done for today. Thank you so much, and see you in the next one.
Thank you all again. Thank you all again.
Bye and have
Bye.
a nice weekend. Bye, everyone.
Have a nice
See ya.
weekend. Bye.